Hello, once again, you are welcome back. As a continuation in the basic operation of indices, let's take a look at the following questions. Yes, I still want to thank those of you who have taken your time off by subscribing to my channel. Thank you. You can still do more by also sharing this video on your social media platform. Now let's get into operation. 625 raised to power 3 over 2 times 5 raised to power half divide 25. Now we look at this 5 here. We can also express 25 using a common base of 5. 625 can also be expressed using a common base of 5. So 625 is the same thing as 5 raised to power 4, and 25 is the same thing as 5 squared. So we replace this with 25 and 5 raised to power 4 with 625, and this become 5 raised to power 4 times 3 over 8 times 5 raised to power half divide 5 raised to power 2. Here we could notice that all the bases are now the same. In that case, we take one of the base and do the necessary operation. For instance, here 4 divide 8 is 2, and this becomes 5 raised to power 3 over 2. Because this is multiplication sign here, become plus half, and this is division sign here, become minus 2 for the powers. Then observing carefully, you can see that 3 over half plus 1 over half, they have a common denominator. All you need to do is just to add the numerator and divide by 2. So 3 plus 1 is 4. 4 divide 2 is 2. So this becomes 5 raised to power 2 minus 2. It become 5 raised to power 0. Okay, and recall that in indices, any base raised to the power of 0 is equal to 1. Now let's look at the second questions. Simplify, evaluate this. 8 raised to power 3 over 2 times 54 raised to power minus half divide 12 raised to power half. Here, all we need to do, because we do not have a common base here, all we need to do is to express each of these numbers, each of these value here, using expressing them as a product of their prime in index form. So for instance, 18 can be expressed as 3 squared, which is 9 times 2, okay, raised to the power of 3 over 2. This become 3 raised to power 2 times 3 over 2 times 2 raised to power 3 over 2. So 2 cancel 2 here. This becomes 3 raised to power 3 times 2 raised to power 3 over 2. So the whole of 18 raised to power 3 over 2 is now 3 raised to power 3 times 2 raised to power 3 over 2. Now let's look for an expression for 54 raised to power minus half. For instance, 54 can also be expressed as 27 times 2, which is 27 on its own can be expressed as 3 raised to power 3. So this becomes 3 raised to power 3 times 2 raised to power 1 raised to power minus half. So, and this can be expressed by using the power here to multiply the power here. So this becomes 3 raised to power minus 3 over 2. So because minus half times 3 is minus 3 over 2. Similarly, minus half here, we multiply this power here, which is 1, and this becomes 2 raised to power minus 1 over 2. So the power outside here only multiply the power inside, okay? It's not the base. So for 12 raised to power half, let's look at an expression for 12 raised to power half. 12 is the same thing, can be expressed as 4 times 3. So which is, and 4 can also be expressed as 2 squared. So this become open bracket 2 raised to power 2 times 3 raised to power 1 close bracket raised to power half. The half here will also affect everything in this bracket, the power in the bracket, and this becomes 2 raised to power 2 times half times 3 raised to power 1 times what? Half. So here this cancel this. So what is left here is 2 raised to power 1 times 3 raised to power half. Okay, so we substitute everything back into this expression. Okay, whatever this of these numbers represent was as expressed in this nature, we will substitute them here, and this becomes 3 raised to power 3 times 2 raised to power 3 over 2 times 3 raised to power minus 3 over 2 times 2 raised to power minus 1 over 2 divide 2 raised to power 1 times 3 raised to power 1 over 2. So for here, 2 raised to power 3, we will collect all the terms containing the base 2, okay? And this becomes 2 raised to power 3 over 2 times 2 raised to power minus 1 over 2 divide 2 raised to power 1. On the other bracket, the base containing 3, this 3 raised to power 3 times 3 raised to power minus 3 over 2 divide 3 raised to power half, as we can see here. Now let's do the necessary operation. Since the base are the same for 2, so this becomes 2 raised to power 3 over 2. Multiplication here is plus, but we're having a minus here. That's why we open this bracket. We have a closed bracket indicating the minus for each operation. Here minus division here minus 1. So for 3 is 3 raised to power 3 plus open bracket minus 3 over 2 close bracket minus half. Now if you look at this carefully, you see that 3 over 2 minus half, the denominator are the same. All you need to do, see the denominator are same, you just do the necessary operation for the numerator. 3 minus 1 is 2. 2 divided 2 is 1. So here this becomes 2 raised to power 1 minus 1. Now for 3 here, let's look at what we have here. 3 minus 1, that gives minus 4. Since this denominator here is 2, so minus 4 divided 2 is minus 2. So this becomes 3 raised to power 3 minus 2. So here 1 minus 1 is 0. This becomes 2 raised to power 0. Then 3 minus 2 is 1. This becomes 3. So here 2 raised to power 0 is 1. So this 1 times 3 is equals to 3. Now let's look at number 3. It says 4 raised to power 1 over 3 times 5 raised to power 2 over 3 divide 10 raised to power 2 over 3. This expression can also be expressed as this, but we have to look at the 4 here and express this as a common, as a prime number in index form. So like for instance, 4 raised to power 1/3 becomes 2 square. That is 4 is the same thing as 2 square times 1 over 3, and this becomes 2 raised to power 2 over 3. For 10 raised to power 2 over 3, 10 can also be expressed as 2 times 5, open bracket, 2 times 5, close bracket, raised to power 2 over 3. This becomes 2 raised to power 2 over 3 times 5 raised to power 2 over 3. So if that is done here, you could see clearly by grouping them. You pick 2 here and pick 2 here. This is division sign here. This becomes 2 raised to power 2 over 3 minus 2 over 3, close bracket. Then open bracket for 5 here is 2 raised to power 3, 5 raised to power 2 raised to power 3, 2 over 3 minus 2 over 3, close the bracket. Here you see that the term here, they are equal to 0. So this becomes 2 raised to power 0 times 2 times 5 raised to power 0 is equal to 1. Let's look at the last question here. 6 raised to power s times 36 raised to power s minus 1 divide 216 raised to power x plus 1. So here, for instance, 36 can be expressed as 6 squared. Similarly, 216 can also be expressed as 6 raised to power 3. So here we will substitute it in the equation here, and this becomes 6 raised to power 2 open bracket x minus 1 close bracket. Here the power here will affect the power x minus 1, and this becomes 6 raised to power 2x minus 2. 2 times s is 2x. 2 times minus 1 is minus 2. So for 216 raised to power s plus 1 is the same thing as 6 raised to power 3 open bracket x plus 1 close bracket, which is 6 raised to power 3s plus 3. So if we put everything here, this becomes 6 raised to power s times 6 raised to power 2s minus 2 divide 6 raised to power 3s plus 3. So here all the bases are now the same. Now what do we need to do? We just pick one of the base and Observe carefully the sign. So, and what sign do we need to replace those signs? So here for multiplication is addition. So 6 raised by s plus uh, 2x minus 2, which is this. For this division, sign here change to minus, and the minus will have to affect the whole of this power. This become minus 3x minus 3. So s plus 2s is 3s. So 3s minus 3s, and that one is off. And here we are left with minus 2 minus 3, that gives minus 5. So the whole expression here becomes 6 raised to the power minus 5, which can also be expressed as 1 over 6 raised to the power 5. 6 multiply itself 5 times is 7,776. Please, if you like this video, hit the subscribe button. Help me share this video so that when similar videos like this come up, you'll be able to have access to them. Have a nice time. See you in my next version.